Students, we are going to discuss about week 2 quantum computing class in which we are going to deal with qubits. So this session is going to deliver the theoretical model of qubits, qubit structures, then qubits types. So this depiction of picture in the slide is revealing the theoretical model of quantum reality, which is holded with three compartments, which is termed to be as independent variable, moderating variables, dependent variables. Independent variable is stating the computability, moderating variables is revealing hardware, software, and applications, and dependent variable is revealing manipulative quantum reality to us. So Feynman is a universal quantum computer, so which has been discovered by the Feynman, the philosopher. The law of physics presents no barrier to reducing the size of computers until bits or the size of atoms and quantum behavior holds away. Vision is a building a universal quantum simulator in the structure of a nature since 1982. Simulate the field theories with the lattice works of spins. So quantum scale, quantum is going to reveal anything in the scale of atomic and subatomic particles. Theme is the ability to manipulate the physical reality at increasingly smaller scales. So quantum is going to hold exponential speedups with a bit of 0 or 1. Qubit is 0 or 1 in superposition. Qubit is more than two values in superposition, where microchip generates two entangled qubits, each with 10 states, 100 dimensions, totally a 6 entangled qubits which could generate. So optics is a material which is revealing time and frequency multiplexing. Existing telecommunication infrastructure is going to reveal this. Global network is going to provide us non-standalone computers in labs. Optics is a material which is revealing the superconductors of inputs and gates. So qubit, which is a triplet, is present in the quantum computing evolution. So it is none other than a quantum mechanical property such as superposition, entanglement, and interference to perform a computational info with 2 power n scaling of 9 qubit systems since 512 states. So that hereafter we will be having a quantum smartphones, which is a technology which is notoriously difficult to predict. I think world market is going to have a very big revolution. So this is the impact of quantum computing in the commercial field. So it is important because it is substantially a new computing paradigm. It is upgrading some sort of global cryptographic standards. It is going to tell the substantial setups in processing powers. Maybe within 10 years, earlier commercial systems such as chipping is going to be introduced also. No one-tier improvement in problem solving complexity is going to be present. So we can try this with 1 minute per month free cloud access D-Wave systems, which is going to throw a program and test algorithms for us. So computational complexity and quantum states is going to reveal some sort of thing in terms of computing resources required to solve a problem. So one tier improvement in computational complexity is going to state the traveling salesman problem, which is going to check twice as many as cities in half the time using a quantum computer. So solving the next tier of designated problem difficulty with current tier's computational resource is going to reveal the exponential space, which is going to clearly state the exponential space, non-deterministic space, deterministic space, and polynomial space for us. So next provider is Google, which is going to reveal the quantum advantage. So first quantum computer to solve the problem classical computers can't solve timely. So there are 53 qubit Sycamore chips, one damaged qubit. Task is random circuit sampling. So Google is going to provide a Sycamore repeats, which is a random circuit sampling process a million times in 200 seconds. So IBM's counterclaim is going to throw a calculation which could perform 2.5 days. So write circuits to 250 petabytes of hard disk, and it is going to check the vector matrix multiplication. So qubit is going to reveal the basic quantum of quantum information with quantum version of classical binary bit. So qubit is quantum information digits. So qubit which is going to hold qubit as well as qubit. Qubit exists with superposition of 0 and 1 being collapsed to a measurement at the end of the computation. Qubit exists in 0, 1 and 2 states until it is going to be collapsed for a measurement of triplet, which is useful for quantum error correction. 7 and 10 qubits tested 4 optical qubits achieved the processing power of 20 qubits. So motivation behind this is it is going to generalize the quantum computing techniques to higher level systems. See, this depiction is revealing as some sort of information like a donut. So qubits are made up of two-level mechanical systems, ones and zeros. This is termed to be as a harmonic oscillatory energies and anachromic oscillatory energies, which is revealing synchronous and asynchronous states. So top three qubit generation methods are architecture, which is arrays, supercomputer conductors, photonics, and trapped ions. Top three qubit generation methods are superconductors, commercial systems, which is an on-premise and cloud-based, IBM and Regati, controlled gate model supercomputers, D-wave systems, the less controllable quantum annealer machines, photonics, and trapped ions. So D-wave systems, quantum annealing, it is going to solve the optimization problems as low energy landscapes. Setup as qubit exists across the landscape in superpositions with zeros and ones, like a fog blanketing the problem space. Annealer cycles is run the fog layer condensed to one point as the global minimum of landscapes. Qubit is going to spin, flip back, forth until settling into lowest energy state of the systems. So readout is lowest energy state is optimal answer. Spin glass analogy, flexible spins funnel to lowest energy. Holographic annealer is going to use ADS and CFT correspondence to map boundary bulk energy operators to read out solutions in one fewer dimensions. So commercial status by platforms is tipping point. So IBM, D-Wave Systems, and Regati Computing. So first method is superconducting circuits, ideal to extend the semiconductor product line, which is uses the existing global fab infrastructure, produce superconducting chips. Superconductors are materials with zero electrical resistance when cooled below a certain critical temperature, more than half of the periodic table elements. Electrons travel unimpeded with no energy dissipations. 20% of electricity is lost due to resistance. At critical temperature, two electrons from weak bond that can tunnel through metal with no resistance is going to be a very big flavor. So key enabling technology is material advancement with room temperature. Implications is cool with liquid nitrogen, not helium. So desktop computing without a bulky cryogenic equipment is going to be a very good popular medium in the commercial market. So 1986 copper coaxium is present. So in 2008 overall aluminium, copper, nibonium has captured the market. So in 2015 lithium and hydrogen sulfide has captured the market. So supercomputing loops which is present in qubits are the junction, which is termed to be as a Josephson junction, which is going to reveal the nonlinear superconducting inductors which create the qubit energy levels. The non-linearity of the Josephson induction breaks the uh, divergence of the energy level spacings, allowing systems to be restricted to only the two qubit states. Junctions need to be produced qubits, otherwise superconducting loop is just a circuit. Linear inductions in a traditional circuit are replaced with Joseph junctions, a nonlinear element that produce energy levels with different spacings from each other that can be used as a qubit. Superconducting loop is a skewed superconducting quantum interference device magnetometer, a device for measuring the magnetic fields. Superconducting circuits Regati, it is a Josephson junction qubit on a substrate. Electrical circuit with oscillating current forms the qubits and is controlled by electromagnetic fields. Substrate embedded in a copper wave guided cavity is going to coupled to qubit transitions to perform computations. Chip is going to alternatively throw fixed and tunable transform qubits. Second method is quantum photonics, quantum mechanical objects, which is going to reveal atom, ion, and photon. Optical circuits do not require error corrections. Global communication networks built on a photonic transfer. Quantum photonics, a single photons represent qubits realized in quantum chips or in a free space. Compute with entangled states of multiple photons. Single photons are sent through the chips or free space for the computations and then measured with photon detectors at the other ends. So continuous qubit optical interface is going to reveal all optical platform from the beginning. Homogeneous qubits with optical interfaces. Method is going to exploit color center defects. So color centers in diamond, color centers in silicon carbide. So the wavelength between two color centers depends on which atom in the lattice is missing and can be used for computation as well. So quantum photonics, diamond center defects method, which is going to introduce impurities to diamond crystal lattice implant ion to create nitrogen vacancies. Nitrogen vacancies produces the FRAP center, a defect as crystal lattice occupied by an unpaired electron. The unpaired electron creates an effective spin which can be a manipulative of a qubit. Quantum state can be initialized, manipulated, and measured at room temperature using the same physics and max for Joseph junction in microchips. So coherence time limited to spin time is going to be produced. So third method is trapped ions. Silicon chips stored deuterium ions in electromagnetic traps, manipulative in computations with the lasers and electromagnetic fields. So ions, it is easier to compute with positively or negatively charged ions. Ytterbium ions do not need supercooling, which is going to hold the long coherence time and requires less error corrections. So trapped ions, which is going to hold the atoms and lasers. Wolfgang Paul Delmet, who is a philosopher who has introduced this method in his research paper, and he has also won the Nobel Prize in 1989. So this manipulation of trapped ions and atoms and quantum state is going to reveal the quantum information bits, which is otherwise called as quantum information bits in terms of qubits and qubits, which is the triplet states in the superposition entanglement, which is going to reveal the state in terms of number 0, 1, and 2. So, dear all, we have closed this qubit varieties and types and the material used for generating this particular bits in the commercial market in this session. Thank you all. Thank you once again.